MSU towards UTEP at 15 miles per hour. The distance between UTEP and MSU is 45 miles. Meanwhile, a dragonfly starts from the UTEP student's bicycle to the NMSU student's bicycle, then back to the UTEP student, going back and forth until the friends meet. The dragonfly travels at 25 miles per hour. So the first question, or the two questions, what is the distance traveled by the dragonfly? How much of that distance is traveled towards an MSU, and how much back towards UTEP?
Anyone have a marker?
I have a red marker here.
Oh, good.
Okay.
So let's just draw the problem quickly. We have one bicycle coming this way, one coming this way. How far are they apart?
45 miles.
45 miles. How fast is he biking? 10 miles per hour. He's biking how fast? 15 miles per hour. And as these two bicycles are racing towards each other, there's a dragonfly that's flying back and forth at 25 miles an hour between the two bicycles. And you have a solution.
Okay. Well, I have two step solutions. On the first one, the very simple was coming back to the physics class, which I thought was going to be worthless. Apparently it wasn't. So the total time until they meet is going to be, since both bicycles are covering the same distance, then what I decided to do is, well, you can say that that velocity plus that velocity is going to take a certain amount of time to cover the 45 miles. So what I did was take the 45 miles and divide that by 25 miles. And
Miles per hour?
yeah, miles per hour.
Cancel out your units.
And then it will cancel out the units and it will give you 1.8 hours. So after 1.8 hours, both bicycles will meet. Then using that,
Did you all do that? They all approach each other at 25 miles per hour. Okay?
so the easy answer to figure out was the distance traveled by the dragonfly was to remember the formula: distance equals velocity times the time. So the total distance that the dragonfly is going to fly is the velocity, the dragonfly, which is 25 miles per hour, and then you multiply that by the 1.8 hours that it's going to take for both bicycles to meet, 1.8. So it turns out to be that the distance that it is going to fly is exactly 45 miles. That was like the easy answer, the intuitive answer that I got. And then to answer the second part, it is kind of tedious and repetitive, so what I'm going to do is I'm just going to do the first iteration, and then do the iteration 4 more times, and it will give you the final answer.
Okay, well, maybe it takes too long. So you showed me this morning. You compute how long does it take to go to the first bicycle, then how long to the second bicycle go back, and how long again, and how long again, until it becomes small enough that he can ignore the answer. More or less, that's what you did,
Yes,
right?
so at the end, I stopped when it was at 1.78 hours. And after the rounding, the distance to NMSU was about 32 miles. And the distance to go to UTEP was about 13 miles, which if you add them is 45, which matches the 45 miles from the previous answer. So that's when I figured out that I'm really right.
So we have a prize.
Yes.
Congratulations.
Yeah, let's get a picture of Dr. Longtay with you there. Hold on.
The legend is that when this problem was asked to von Neumann, because usually you think, okay, you calculate this, and you calculate this, you calculate this, and then you do an infinite series, and then you sum the infinite series. But there's a very easy solution. When they asked a problem to von Neumann, they ask him the question and he answered immediately. He said, well, that's very good. Most people actually sum the infinite series. I said, I did sum the infinite series. Okay. I had prepared some answers and I have some spreadsheet which I'm not going to show you because
So put them up on the web or...
but anyway, as you know me, I guess by now, I like graphics. So if you have the distance here, can you see? And then you plot the distance against the time. One bicycle goes at 10 miles per hour, it will be this curve, right? The other bicycle starts from here and goes at 15 miles per hour, so it'll be like this with a different slope. You can calculate the point where they meet, which is this formula that he did here. Okay? And sometimes you can, now I refer to the ground, but you could also have another curve which is even more easy to do. If you do it relative to this bicycle, then it's just a triangle with a right angle. So now the fly, or the dragonfly, is going at this speed, which is a slower slope, so meets here, and then meets here, then meets here, etc., up to infinity. So the way to compute this without using infinite series is, you notice you can compute this. It's the same thing as this, but it's a different speeds, right? Now you can compute the distance here and the distance here. So now is a new distance. Then you can solve another version of this problem here. Then you can compute here. Now you can compute what is the ratio of this direction to this direction. Okay, so it looks like about this is 1/3, 2/3. Now if you look at this graphic, this is the same triangle as this, but smaller. So the ratio will be preserved through the rest of the thing. So you can multiply the 45 miles by this ratio and get this without doing infinite series. Now you add the wind. Does it complicate the problem? Everybody thought it becomes almost unsolvable. Well, you change the slope here a little bit, you change the slope here a little bit, you change the slope here one direction, you change it the other direction because the wind helps and hinders. And then, so the only complication is you have to compute the ratio first. And once you have the ratio, you can compute the average speed. Okay, in one direction was 20, the other one was 25. And if 75% at the time here and 25% of the time here, you can compute the average speed. Then you multiply by this and solve the second problem without infinite series. And are you curious? Let's verify his answer here. For the first problem, distance towards NMSU, 31.5, and 13.5. Okay, you were half a mile off. Rounding, right? Okay, thank you.